This video will cover the Geometry Regents exam from June 2015, questions 32 through 34. Number 32 says, using a compass and a straight edge, locate the midpoint of AB by construction. Now we know that a midpoint comes out of a bisector, so that means that we can construct the perpendicular bisector. So this is where we start with our center on A and open up your radius to about 3/4 of the way. As long as you're more than halfway, then you're going to be okay. So what we're going to do is open up our radius to here and swing an arc above and below. Now, of course, yours is supposed to look much nicer because you have a compass. I'm just doing this freehand. Don't do it freehand. You will not get full credit. Actually, you won't get any credit. Then we're going to switch and put our center on B. Notice that when you do this, you need the same radius. Otherwise, you're not going to get a point exactly in the middle. So I'm going to, again, keep my radius about 3/4 of the way. Whatever it was the first time, I'm going to keep it. I'm going to swing above and swing below. My next step is to actually put that bisector in there, so that straight line that connects those 2 points of intersection on your arcs. But because we're asked to find the locate the midpoint, we have to actually indicate that this point in which the perpendicular bisector crosses our line, that point is the midpoint, say M. You can put whatever letter you want there as long as you locate it, meaning put a point on it. Call it out. Tell the person grading this paper that this is the midpoint. 33 says the coordinates of the endpoints of CD are C and D with coordinates. Express the length of CD in simplest radical form. Now, length is related to a formula called the Pythagorean Theorem. And so what we can do is set up a table. Change X, change Y, Pythagorean Theorem. So change just means to simply subtract. So we're going to subtract X values, subtract Y values, and then plug in. So we have 3 minus 6. If you need to, go label these x1, y1, x2, y2. Subtract X values. Then also subtract Y values. But notice we have this double negative right here, which then, of course, turns to positive. So change X becomes 9, and change Y becomes -3. This -3 is going to get plugged in for A, and B will be 9. But because we're plugging into Pythagorean Theorem and things get squared anyways, we can just say that A is going to be +3. Because if I were to square -3, that would still give me 9. If I were to square +3, that would still give me 9. It doesn't matter whether it's positive or negative because squaring changes the sign. So we have 3 squared plus 9 squared equals, say, x squared. We're trying to find the length. So we have 9 plus 81 equals x squared. 90 equals x squared. But we know that when we find x by taking the square root, 90 is not a nice perfect square, which is why they tell you to write your answer in simplest radical form, meaning break it down. So I'm going to list my perfect squares off to the side because I need to find a perfect square that goes into 90. So we have 1 times 1 is 1, 2 times 2, 4, 3 times 3 is 9, 4 times 4 is 16, so on and so forth. So you're just going to keep multiplying numbers by themselves. 36, 49, 64, 81, and 100. So I'm going to start from the bottom of my list and work backwards because I want to find the largest perfect square that goes into 90. Obviously 100 is too big. 81 does not divide evenly into 90. 90 divided by 64 is not nice. Divided by 49, not nice. 36, 25, 16. All the meantime, you're testing this in your calculator. 90 divided by 25. 90 divided by 16. And lo and behold, 90 divided by 9 gives you 10. So I always put the perfect square first and the non-perfect square second. Because when I simplify this, notice again that the reason we did the square root is so that the square cancels out. When we simplify, we have square root 9 turns into a 3. Square root 10 stays the same. So we get x equals 3 radical 10, which is our final answer. 34 says, in the diagram below, point B is the incenter of triangle FEC. Now, incenter is not a very common word. I'm actually surprised they put it on this exam, but it just means it's the point formed by the angle bisectors. Point formed by angle bisectors. which then in turn means that each of these pairs of angles, adjacent angles, are congruent. So the measure of angle FEC, this huge angle up here, is 84. Measure of angle ECF, this huge angle, is 28. Our goal is to determine and state the measure of angle BRC right here. So I'm going to choose to call this X, put it over here, box it in. That's what I'm trying to find. So if I look at this picture, we have, it seems as though we have several different options. But I think the easiest option is going to be to focus on this triangle right here, because that encompasses all of angle BRC. Even though it extends out to E, that's okay. It encompasses all of it. So because I know that these two angles up here are congruent to one another, because this is an incenter, which means this is an angle bisector, I can take that 84 and divide it by 2 to give me 42. Because now that means that this angle is 42 and this angle is 42. I can do something very similar to the 28. That angle of 28 degrees gets cut in half to give me 2 congruent angles. And so here I'm going to take 28, divide by 2 to get 14. So I have 14 degrees, 14 degrees. Now I didn't necessarily actually have to split that angle up, because what we're looking for here is this huge triangle. So if I redraw it, we have X, we have 42, and we have that whole angle of 28 degrees, because I need both parts. So now we have X plus 42 plus 28 equals 180. 3 angles in a triangle always sum to 180. So we have X plus 42 and 28 sum to 70 equals 180. So then when we subtract 70, we get X equals 110. So our final answer should be measure of angle BRC equals 110. Because again, we chose to call it X originally.